How your immune system works and transfer factors' role. The immune system is like a police force. It patrols everywhere, and if it finds a disturbance, it calls for backup. In this way, it is different from other systems in that it has to be able to react in any part of the body. The immune system provides two levels of defense, innate and adaptive immunity. This discussion will begin with a brief description of the organs and tissues associated with the immune system, and then focus on the cells that provide innate and adaptive immunity. If the immune system is a police force, the bone marrow is the police academy, because this is where the different types of immune system cells are created. All cells of the immune system are created in the bone marrow from a common type of starting cell called a stem cell. Some of the stem cells will become a type of immune system cell called a lymphocyte. Two types of lymphocytes comprise the adaptive immune system, B cells and T cells. B cells mature in the bone marrow, hence the name B cell. Cells that eventually become T cells travel from the bone marrow to the thymus by way of our bloodstream, where they mature, hence the name T cell. The thymus is located just above the heart, behind the sternum or breastbone. There is an innate system and adaptive system within the immune system. The innate system recognizes self-markers on the surface of each cell in a combination that is almost unique for each person, thereby enabling the body to distinguish self from non-self. The innate cells consume any threat that doesn't have self-markers. These innate cells present the characteristics of the threat to B cells, which in turn creates antibodies. Antibodies are like wanted posters floating through your immune system looking for the characteristics of a particular threat. Generally, there are only two ways to create these wanted posters, either through actual contact with the pathogen or parasite or through a vaccination. Transfer factor is the third way. Transfer factors carry the characteristics of any pathogen or parasite that the cow or chicken has come in contact with. Chickens and cows are exposed to pathogens that are cousins to human pathogens. The difference between antibodies and transfer factors is that antibodies can only alert the immune system if the pathogen has characteristics exactly like the characteristics carried by the antibody. Transfer factors do not have to be an exact match and can alert the immune system if the characteristic is anywhere close. Transfer factors are considered cytokines. Cytokines are communication molecules that communicate between immune system cells. Transfer factors connect to several different immune system cells and cause those particular cells to release other cytokines to alert other categories of immune system cells which function as a team of attackers against these threats. Transfer factor molecules can affect other cytokines that can upregulate and downregulate the immune system. Also, transfer factors can cause B cells to produce antibodies. Transfer factors can affect smaller molecules called nanofactors that can manage the actual battle between the pathogen and the immune system's police force. When pathogens enter your body, there's a race between the criminals and the police force on who can reproduce faster. Transfer factors help your immune system respond faster and relax faster. Transfer factors also influence the production of several antioxidants.